Good morning, students. Myself, Professor Bankar, DB, Department of Chemistry, RBNB College, Srampur. In previous lecture, we have seen about the basic introduction about quality of irrigation water topic from agriculture chemistry of T.Y.B.Sc. class. So, in previous lecture, we have seen about what is mean by pure water, then various sources of the water. Then we have also seen about the various types of impurities present in the given water. In that impurities, some impurities may be dissolved form, some impurities may be in the form of suspended particles, some impurities may be of biological nature, like that. In this lecture, we will going to learn about dissolved constituents in water. Dissolved constituents in basically irrigation water. So in irrigation water, there are various kinds of dissolved impurities are present. The concentration of that impurities are expressed in parts per million, that is ppm. The concentration of that dissolved impurities is expressed in terms of ppm. Basically, there are two classes of dissolved impurities. First is major constituent and second is minor constituent. If the particular elements or impurities are present in a large amount in the given irrigation water, then that impurities or constituent can be classified into the major constituent, and if that impurity is present in trace amount, then it belongs to the minor constituent. So we will see what are those major and minor constituents present in the given irrigation water. So first class is major constituents. First class is major constituent. So it includes different types of elements such as calcium, magnesium, that is Mg, then sodium, that is Na, potassium, that is K, carbonate, that is CO3 2-, then bicarbonate, that is HCO3-, then sulfate, that is SO4 2-, chloride, that is Cl-, and nitrate, that is NO3-. In the given irrigation water, this type of various elements can be present in a large amount and their concentration is expressed in terms of ppm. It includes calcium, magnesium, sodium, potassium, carbonate, then bicarbonate, sulfate, chloride and nitrate. So this is about the major constituent. So then we will see the what are various minor constituent present in the given irrigation water sample. So minor constituent include boron, that is B, silica, SiO2, nitrite, NO2 minus, sulfide, S minus, and fluoride. That is F minus. So minor constituent include boron, silica, nitride, sulfide, and fluoride. So this type of, we can say, impurities, constituents may be present in single form, they may be present in salt form, or sometime they may be present in the complex form. So depending on their concentration, that is their concentration is very less in the irrigation water, therefore they belong to the minor constituent. Next point is water quality indices or water quality standard. Next point is water quality indices or water quality standards. It is generally essential to express the various types of parameters, we can say indices, standards, in order to check the feasibility of given water for the agriculture purpose. So with the help of certain standard parameters or indices, we can study whether that given water is good or not for the agriculture purpose. So we can judge the effect of this type of indices on the soil factor. So first indices is total soluble salt. Total soluble salts, that is TSS. Total soluble salts, that is TSS. So total soluble salts or total concentration of the different types of elements present in the given water is one of the important factor to determine the quality of the given water for the agriculture purpose. If that given water consists of huge number of soluble salts, then such water is not good for the agriculture purpose. So this is one of the important factor for the agriculture purpose, that is total soluble salts. That salt should be less. Some salts are beneficial and some salts are harmful to the given soil, to the given microorganism in the given soil. The total soluble salts in the given water can be determined by the conductivity. If that particular water sample has large number of soluble salts, then that water gives good conductance. So with the help of this type of technique, we can determine the total soluble salts. Then second parameter is sodium adsorption ratio. Total indices standard parameter is sodium adsorption ratio. Basically, the presence of sodium in water, presence of sodium in water is the sodium adsorption ratio. The presence of sodium in the water is the sodium adsorption ratio. So this sodium adsorption ratio is calculated by the formula, that is SAR is equal to Na plus upon square root of Ca2 plus Mg2 plus upon 2. If we know the concentration of Na plus, Ca2 plus, Mg2 plus, then we can calculate the sodium adsorption ratio by using this particular formula. Next standard is exchangeable sodium percentage. So it is used to determine the relationship. It is used to determine the relationship with SAR, which determine the quality of water, Both ESP and SAR are related with each other, and this ESP is used to determine the relationship with SAR. If we compare the ESP and SAR, then we can determine the quality of given water. And last parameter is residual sodium carbonate. Last parameter is residual sodium carbonate. That is RSC, residual sodium carbonate. So this is also one of the important factor. Basically, in the soil, or we can say that calcium in the water, the calcium react with carbonate. And it form as calcium carbonate. There is precipitation takes place and formation of calcium carbonate. Calcium can react with carbonate. Precipitation of calcium carbonate can be formed. So due to this, what happen? As calcium and magnesium lost from the water, then what happen? There is increase in relative proportion of sodium. And this increase in relative proportion of sodium is termed as residual sodium carbonate. So that increased amount of sodium due to the removal of calcium and magnesium is not good for the given water, given soil. So that increased amount of sodium is hazardous to the given water, to the given soil. This increase in sodium proportion is termed as residual sodium carbonate. So there is some standard values of all these parameters. If that parameter follow the standard value, then that water is good for the drinking purpose, good for the agriculture purpose. If the value of particular parameter is very much high or very much low, then that water is not safe for the agriculture, for the drinking purpose. So that value should be optimum. So with this quality of irrigation chapter is completed. In next lecture we will start the next part of this particular course. Here I will stop. Thank you.